In this video we're going to show how we can assign oxidation numbers to elements in compounds. There are 5 guidelines that we use to assign the oxidation numbers, and these can be found in the description below. In the first one, all elements in the pure form have got an oxidation state of 0. So if we take some elements such as oxygen or iron or chlorine, they all have an oxidation state of 0. The second rule shows that monatomic ions have got an oxidation state matching the charge of their ion. So if we take a compound such as potassium chloride, and we want to work out the oxidation state of chlorine in potassium chloride. Well, potassium is in group 1, has a charge of +1, so it has an oxidation state of +1. This means to say, because it's a neutral atom, the total of the oxidation states must equal 0. Therefore, chlorine must have an oxidation state of -1. Another example for this would be for the compound lead 4 chloride. Say we wanted to find out the oxidation state of lead. Well, we know as a monatomic ion, chlorine has got the oxidation state -1. Therefore, as there are 4 chlorines, total -4, in order to make it a neutral compound with an overall oxidation state of 0, lead must have an oxidation state of +4. +4, take away the 3 -1 chlorines, overall 0. For our third rule, oxygen within a compound has got an oxidation state of -2, unless it's found in a peroxide. So if we take an oxide, let's take magnesium oxide, and we want to calculate the oxidation state of magnesium. Well, this is just a normal oxide, therefore oxygen has got an oxidation state of -2. This means to say that magnesium, because it's a neutral compound, must have an oxidation state of +2, so when they're added together it equals 0. However, if we take a peroxide such as sodium peroxide, the other peroxide that you need to know is hydrogen peroxide. In this we know that sodium has got an oxidation state of +1. There are 2 of them, therefore total oxidation state for both sodiums would be +2. There are also 2 oxygens and no charge on the overall compound. So if we've got 2 oxygens that must total -2, each oxygen now must have an oxidation state of -1. So in a peroxide, the oxidation number for oxygen is -1. The fourth rule is for hydrogen when it is in a compound. Hydrogen in a compound has an oxidation state of +1, except when it's in a metal hydride, when it has an oxidation state of -1. So if we take a compound such as hydrogen bromide, bromine has got an oxidation state of -1, therefore the hydrogen has got an oxidation state of +1. If we now take a metal hydride, let's simply take sodium hydride. Sodium has got an oxidation state of +1. This means that hydrogen in a metal hydride must have an oxidation state of -1. The last rule for oxidation numbers is the sum of oxidation numbers in a polyatomic ion has to equal that of the ionic charge. Let's take the sulfate ion for example, and we're going to work out the oxidation state for sulfur. What do we know? We know that oxygen from our rules has got an oxidation state of -2, and there are 4 of them, therefore the overall oxidation state for oxygen within the sulfate ion is -8. Now if the total of this total oxidation state of the whole ion has to equal -2, and we already have an overall oxidation state of -8, then sulfur must have an oxidation state of plus 6, because -8 plus +6 equals -2. Let's now look at using the rules to work out the oxidation state of a couple of compounds. First of all, let's take hypochlorous acid, HOCl. And we're going to work out the oxidation state of the chlorine. Now the way I like to do this is to have the oxidation numbers of the elements totaled below and the actual oxidation number of the elements above. So in this example, hydrogen has got an oxidation state of +1, and there's only one of them. Oxygen has got an oxidation state of -2, and there's only one of them. The overall charge is 0. Therefore, chlorine must have an oxidation state that when these things are added together equals 0. So +1 plus -2 is -1. Therefore, the oxidation state of chlorine must be +1. Now this is different to what you already know, that chlorine's in group 7 and has a negative charge. This shows that elements can have variable oxidation states. We're trying to work out the oxidation state of manganese. Potassium has got an oxidation state of +1. There's only one of them, so the total oxidation state for potassium is +1. Oxygen has an oxidation state of -2, but there are 4 oxygens, therefore the total oxidation state is -8. For potassium permanganate, there is no charge on the overall molecule. Therefore, we have to balance this to 0. In order to work out this out to 0, for the manganese ion, -8 and +1 comes to -7. Therefore, the manganese must be a +7 oxidation state. As there is only one of them, manganese overall is +7. Finally, let's take the dichromate ion, Cr2O7 2-. What we know already, if we're going to calculate the oxidation state of chromium, is that oxygen has got an oxidation state of -2. There are 7 oxygens in the dichromate ion, so the total oxidation state for all of the oxygens is -14. Now it's important to note this ion has a charge, -14, and we need to have an overall oxidation state for the whole compound of -2. Therefore, chromium must have an oxidation state of +12. +12, take 14, is -2. There are, however, 2 chromiums in this. Therefore, each chromium itself must have an oxidation state of +6. And it is the +6 that you would quote if you were going to give the oxidation state for chromium in dichromate.